It's a dust storm! Alright, so I know that I'm super late to the game on this whole dust story, and nearly every major media outlet has already been covering it for the past 2 weeks continuously. But you know what? There's still people out there talking about it, so will I. And besides, I bet you ain't never seen a dust story like this one. So, just for a little bit of background in case you missed it, for the past 2 weeks, a massive cloud of dust has been crossing the Atlantic Ocean and impacting parts of the Americas. It's been making headlines throughout major media outlets along the way.
A gigantic dust cloud nicknamed Godzilla.
That massive dust cloud blanketing several states,
darkening the skies in the south.
See that we have a team of meteorologists tracking it.
Now, for this video, we're going to take a basic look at some of the impacts of dust. But first, we're going to take a thorough look at how these storms develop, and more importantly, how this current one got started. To do this, we have to first leave the Americas and cross the Atlantic Ocean to Africa. There, 5,000 miles away, lies the Sahara Desert, the largest hot desert in the world. At over 3.5 million square miles, the Sahara Desert is actually larger than the continental United States. Just south of this desert is a region where summertime thunderstorms are common. Wait a minute, you're here to learn about the dust storms, so what does that have to do with thunderstorms? Well, actually, quite a bit. Thunderstorms develop from warm air rising very quickly. The upward motion, or the updraft of the air, is what creates the towering cumulonimbus clouds that house thunderstorms. But with all that air going up, at some point it must come back down, and that is what is called a downdraft. Now, many downdrafts are too weak to be felt on the ground, but when downdrafts are very strong, they do reach the ground. The result is literally a sudden burst of air descending from the clouds and crashing into the ground. In Africa, if one of these thunderstorms and their strong downdrafts occur near or over the Sahara Desert, dust and sand that has settled on the ground can easily be projected into the air. The result is the formation of a large dust cloud around the storm. If strong and persistent winds above the surface, known as the easterlies or the trade winds, are present, the dust cloud may be transported hundreds of miles, and in some cases, far enough to cross the Atlantic Ocean. On a miniature scale, it looks something like this. Using this basic model and concept of how dust storms form, we can use it to track the development of the current storm. Back on June 14th, a large thunderstorm complex developed over the country of Niger. The storm, depicted in this satellite imagery as a rosy, deep red color, raced eastward through the country of Mali and onto the west coast of Africa. However, if we look closely at the rosy red storm, we notice that there's a vivid magenta and pink area just along its northern edge that kind of flashes a little bit. This pink area is the satellite detecting dust that has likely been blown into the air by the storm's powerful downdrafts. As the storm races toward the coast, the dust tags along and actually grows in size. Using a different type of imagery, we can see that at the same time, strong trade winds were also present in the area. These trade winds blowing across the Atlantic Ocean are actually the same ones that allowed the early European voyagers to sail across the Atlantic during the Age of Exploration in the 15th and 16th centuries. They're also the same trade winds that would later fill the sails of the slave ships during the Atlantic slave trade. If we continue to watch our satellite loop, we can see how the dust cloud expands out of Africa and into the Atlantic Ocean as this vast pink cloud. Over several days, the cloud moves across the Atlantic Ocean, eventually reaching the Caribbean islands. Just like in our model, we can see exactly what it was like as the cloud overspread the Caribbean islands. These images that you're currently seeing, these are from when the dust cloud arrived in Puerto Rico. Several days later, around June 25th, or about 11 days after it was first stirred up, the dust finally made it to the United States mainland. While it was much more diluted than earlier in its trip, it still managed to produce hazy skies and vivid sunsets across parts of the southeastern states. The wind pattern over the United States since then has been such that New York and the northeastern states have been generally shielded from the dust cloud. Instead, some of it continues to linger in the air over the southern states, while parts of the cloud have been blown back out to sea. So, how common are these dust storms, and what kind of impacts can they have? While dust storms only manage to fully cross the Atlantic Ocean every few years, their presence over the ocean is very common, especially during the summer months. The vast clouds of dust that routinely blow out of the Sahara Desert and over the Atlantic Ocean are known as the Saharan air layer. And this Saharan air layer has been studied since the 1970s. In recent years, there have been several dust clouds that have garnered media attention, but social media searches spike nearly every year during the summer months. Prior to this year, the most recent big transatlantic dust cloud was back in 2018, so only 2 years ago. And it isn't just the Americas that can be impacted. The dust can just as easily blow northward into Europe. It all just depends on which way the winds are oriented. Now, due to their massive size, these dust clouds can impact everything from weather patterns to ecology to human health. The Saharan air layer, or the seasonal dust cloud, when present over the Atlantic Ocean, routinely suppresses hurricane activity. The dry, dusty air inhibits moisture that is needed for hurricane development, and the shade that these massive clouds cast can decrease ocean temperatures if present for long periods of time. Over land, the dust also plays a vital ecological role in replenishing soil nutrients in areas such as South America. In these areas, such as the Amazon rainforest, drenching seasonal rains continually wash away nutrients and send them out to sea. But the millions of tons of dust that blow out of Africa every year play a role in returning minerals to the land. And when it comes to human health, studies have shown that there are often negative impacts. When the dust clouds move over land, the presence of suspended particles in the air often severely decreases air quality. This can exacerbate respiratory conditions such as asthma, creating groups of vulnerable populations. While there isn't a way to stop these dust storms or their associated impacts, the fact that we can see them in real time from space, coupled with the fact that it takes 5 to 7 days just for the dust to cross the Atlantic Ocean, means that people in the Americas generally have a significant amount of warning time as these massive dust clouds are approaching. Because of this, people who are in vulnerable populations, such as those with respiratory conditions, can be advised well in advance to take precautions or shelter in place until the dust has settled. So, that's the dust cloud. Hopefully you have learned something new about it, so when the next one rolls around, probably later this summer, you will have a better understanding of what it is, where it came from, and what potential impacts it might have. That's it. Keep being awesome, and I will see you next time.